Earthquakes are one of the most powerful and destructive forces in nature. They can occur without warning, causing widespread damage and loss of life. But what exactly causes these tremors? In this video, we will explore the science behind earthquakes, examining the forces that cause them, how they spread, and the technology used to predict and measure them. At the most basic level, earthquakes are caused by the movement of tectonic plates beneath Earth's surface. The Earth's lithosphere, the rigid outer shell of the planet, is divided into large sections called tectonic plates. These plates float on the semi-fluid asthenosphere below them, which allows them to move slowly over time. The movement of these plates is driven by heat from the Earth's core, causing them to shift in different directions. As the plates move, they can either move towards each other, away from each other, or slide past one another. These interactions occur along fault lines, cracks in the Earth's surface where two plates meet. When two plates grind against each other, they build up stress over time. The stress is caused by friction between the plates, which resist moving past each other. Eventually, the pressure becomes too great, and the plates suddenly slip along the fault line, releasing the stored energy in the form of seismic waves. This sudden release of energy is what we feel as an earthquake. There are three main types of faults where earthquakes are most likely to occur: normal faults, reverse faults, and strike-slip faults. In a normal fault, one plate moves downward relative to the other, creating tension along the fault line. In a reverse fault, one plate is forced upward over the other, creating compression. Finally, in a strike-slip fault, the plates slide past each other horizontally, causing shear stress. Each of these faults creates different types of seismic activity, but all result in the release of energy that causes the ground to shake. While the majority of earthquakes occur along plate boundaries, they can also happen within plates themselves, in what are known as intraplate earthquakes. These earthquakes are less common, but they can still cause significant damage. For example, earthquakes in places like the central United States, away from major plate boundaries, are rare but can be devastating when they occur. The energy released during an earthquake travels through the Earth's crust in the form of seismic waves. These waves move at different speeds depending on the type of material they pass through. The two main types of seismic waves are P waves, primary waves, and S waves, secondary waves. P waves are the fastest seismic waves and are the first to be detected by seismographs. They move in a push-pull motion, compressing and expanding the material they travel through. S waves, on the other hand, are slower and move in a side-to-side motion, causing more ground shaking. S waves are typically responsible for the most damage during an earthquake. When an earthquake occurs, it generates a shockwave that radiates outward from the point of rupture, known as the epicenter. The energy from these waves travels through the Earth's crust, reaching the surface and causing the ground to shake. The intensity of the shaking depends on factors like the magnitude of the earthquake, the distance from the epicenter, and the geological characteristics of the area. The magnitude of an earthquake is measured on the Richter scale, which quantifies the amount of energy released during an earthquake. The scale ranges from 1 to 10, with each number representing a tenfold increase in the amplitude of seismic waves. For example, a magnitude 6 earthquake produces seismic waves that are 10 times larger than those of a magnitude 5 earthquake. The energy released by larger earthquakes can cause widespread destruction, while smaller quakes may only cause minor shaking or go unnoticed. Another important factor in the impact of an earthquake is its depth. Shallow earthquakes, which occur within 70 kilometers of the Earth's surface, tend to cause more damage because their seismic waves don't have as far to travel before reaching the surface. Deeper earthquakes, on the other hand, may have less impact at the surface, though they can still be felt in some cases. The depth of an earthquake is measured in kilometers and is an important factor in determining the extent of its effects. In addition to the immediate shaking, earthquakes can also trigger secondary hazards, such as tsunamis, landslides, and fires. For example, when an earthquake occurs under the ocean, it can displace large amounts of water, generating a tsunami. These waves can travel across vast distances, causing destruction when they reach coastal areas. Landslides can occur when the ground shakes, causing rocks, debris, and soil to move downhill, potentially burying homes and infrastructure. Earthquakes can also cause ruptured gas lines or damaged power lines, leading to fires that can compound the damage. Scientists use a variety of tools and methods to monitor and study earthquakes. One of the most important tools is the seismograph, a sensitive instrument that records the vibrations of the Earth. Seismographs measure the time it takes for seismic waves to travel from the earthquake's epicenter to different locations, allowing scientists to determine the location, depth, and magnitude of the earthquake. By studying patterns in seismic activity, scientists can also identify areas at higher risk for future earthquakes, helping to improve safety measures and preparedness. In addition to seismic monitoring, geologists also study fault lines and the movement of tectonic plates to better understand earthquake risks. By examining historical records of earthquake activity, scientists can make predictions about where and when earthquakes are most likely to occur, although exact predictions remain challenging due to the complex nature of tectonic processes. Earthquake preparedness is an essential part of living in earthquake-prone areas. Communities in regions with high seismic activity are often required to build structures that can withstand the shaking of an earthquake. These buildings are designed with special materials and techniques, such as reinforced steel frames and flexible foundations, to absorb seismic energy and minimize damage. Additionally, earthquake drills and early warning systems can help people respond quickly in the event of an earthquake, reducing the risk of injury or loss of life. In conclusion, earthquakes are powerful and unpredictable natural phenomena caused by the movement of tectonic plates beneath the Earth's surface. While scientists have made significant advances in understanding how and why earthquakes happen, there is still much to learn about these seismic events. By studying earthquakes and the forces that drive them, scientists can improve safety measures, enhance early warning systems, and continue to uncover the mysteries of our planet's dynamic interior.